look at the so-called obvious solution to this problem. Now notice that the exponent up there is actually a variable, and the variable expression is x cubed minus 63. Now, wouldn't it be nice if that exponent was equal to 1? Okay, notice that x cubed minus 63 is the variable expression for the exponent in both cases. Now you have a different base, but if this is equal to 1 and this is equal to 1, it's clear that the solution to this equation, x equals 4, is the obvious solution. All right, but notice we're looking for an x that is a real number but not a natural number. So you could actually set theoretically right here, say that 4 is not a member of, some people call that r minus n, just r backslash n, I guess. The set theoretic difference. Okay, so 4 is a solution, but it's not in the set of numbers we're interested in. Okay, so let's move on down and look at this next fairly natural attempt. Now notice we said x cubed minus 63 equals to 1. Well, based on what you know, remember b to the minus 1, any base raised to a negative power, in this case minus 1, means the very same thing as 1 over b, right? Okay, so and what we know about conjugate arithmetic makes this actually fairly straightforward. You can follow along here. I just wrote it all out to save you guys having to watch me write it down. But this expression is equal to this expression. Combining to get a single fraction, we get this expression right down here. Again, folks, it's not really cross multiplication, but it has that crisscross applesauce sort of pattern here. Now, what makes this thing fly is this difference of 2 squares result. This is actually equal to, I think, 289. 289 minus 288. Right? And so you see how this works out very, very nicely here. That's just equal to 1. And so we can see in the very same sort of fashion, if this is equal to 1, the whole expression is also going to be equal to 34. Hope that's not confusing. I hope that makes sense, you guys. I was being lazy right here. This expression right here turns out to be 1 conveniently. And so again, we get 34 is our solution, which is what we're looking for. Let me see if I can keep this on the same screen. So in a similar fashion, just like we equated this to 1, we're going to equate x cubed. And this will be the solution that we're interested in, x cubed minus 63 equals to negative 1. Okay, now when you add 63 to both sides and take the cube root, you get x equals to the cube root of 62, which is certainly not a natural number. So let me get that written down for you. The cubed root of 62, and that's certainly a member of r backslash n, or it's the real numbers with the natural numbers cut out, so to speak. So this is our answer, ladies and gentlemen. Now I know that a little bit of inspiration was required to even try this, but if you're familiar with working with conjugate surds, you know that this is at least an attempt. And I'm not claiming that this is the only solution. Nowhere, am I saying that's the only solution, because I was careful with my indefinite article. I said find an x. I think there's a lot of complex solutions to this, but we did satisfy the conditions of the problem, and I guess that's all I have to tell you guys. Oh yeah, this part right here, this is, this is your standard a plus b, a minus b setup right here. This part would be a plus b, right? And this part right here would be your a minus b. And of course, when you multiply, that's just called the difference of two squares. The AB terms cancel. Okay, so this part right here would be your a squared minus b squared. It's just, and again, that's this whole kind of, this type of algebra is why you would even think about using -1 as a possible solution, okay, or as a possible exponent. So this is a squared minus b squared. And this really isn't, like I say, a general way to solve this problem. It's sort of, like I say, a little bit of divine inspiration, but it's not too much of a leap of faith in my humble opinion. Okay, hope you enjoyed.